warm greeting. What is a sequence? A sequence is an ordered list of numbers. But what is an ordered list? How can I define this mathematically? Here comes the definition of the sequence as a function. A sequence can be regarded as a function from the set of natural numbers to the set of real numbers. That is, to each positive integer from the set of natural numbers, there is assigned a number in the set of real numbers. Therefore, an infinite sequence is an endless succession of numbers written down according to some definite law. There are some technical terms that we should know before we proceed further. The set of all distinct elements of the sequence is called its range. Since a sequence is a function from n to r, its range is the range of the function. The terms of the sequence need not be distinct. The range of the sequence may be finite or infinite. Now, it is time to see something more important. An idea which we will be using throughout the course. A definition that will be used in almost all the theorems. Can you guess? Yes, the definition of convergence. Instead of defining the convergence mathematically, let us try to visualize the convergence through an example. So, what is convergence? The word itself says the meaning. If a sequence seems to approach a finite limit, we say the sequence is convergent. Wait, what? Approaching a finite limit? What is approaching then? That means they are coming closer to each other. Particularly, coming closer to the so-called limit. But how can I say two numbers are getting closer? Let us try to understand from an example. When will you say two persons are standing close to each other? Can you guess? Yes, you can tell by looking at them. But how can I say this technically? Can you imagine? Of course, if the distance between them is comparatively small, then we may say they are standing next to each other. The same idea applies here. The idea of distance. To define the convergence, particularly, to compare the distance between the limit and terms of the sequence, we introduce a parameter epsilon. Hence, we say the sequence is convergent if the modulus of an minus l is less than epsilon, where epsilon is an exceedingly small positive quantity. In one-dimensional analysis, the modulus of b minus a gives the distance between a and b. Still, the definition is not clear. Can we say all the terms of the sequence will satisfy the inequality? If not, then what are all the elements that will satisfy the inequality? What about the epsilon? Can I change the value of epsilon? Since the comparison differs from person to person. Therefore, we must be clear defining the convergence so that nobody questions us. We are left with two questions. First, what are all the elements that will satisfy this inequality? Second, is the choice of epsilon particular or random? Look at this example. The terms that satisfy this inequality varies with the choice of epsilon. When epsilon is 0.1, from and after the 11th term, satisfy the inequality. But when epsilon is 0.05, from and after the 20th terms, satisfy the inequality. It's time to define the convergence of a sequence. Let's do it. Given epsilon greater than 0, there exists a natural number m such that the modulus of an minus l is less than epsilon, for all n greater than or equal to m. Yes, we did it. Thank you.